Hi guys, it's Mrs. Brabant. So these are the targets we worked on this week, and here's some other examples that I'm going to go through to make sure that you are okay with each target for Unit 5. So as you remember, we're going to take this radical, look at the number underneath, which is the radicand, and we're going to split it up into two factors. And we're going to try to choose one of them. It can be the largest possible biggest perfect square, which is 9, that goes into 63. So we know 9 times 7 is 63. So now what we need to do is look at each one here, and if it can be broken up again into another perfect square, we're going to do that. So if we find a perfect square, because we're looking for pairs, we want to pull it out of the radical. So this is a perfect square, so it's going to come out as a radical, because we know 3 times 3 as a pair is 9. This here, 7, well, it can be broken up into like 7 and 1, so there's neither of those as a perfect square, so that means to us it does not get to come out of the radical. So our final answer for simplifying the square root of 63 is just 3 root 7. And if you want to check your work, you can put this in the calculator and this in the calculator, and you should get the same decimals, and that'll tell you that you did it right. If you don't get the same decimal, that means you need to go back and check what you used as your factors, because you probably just picked the wrong numbers. All right, so 120 is a little longer, a little larger, and there's so many ways you can split this up. And if you're not comfortable with picking big perfect squares, you can still just break it up any way you want, and then look for groups of 2. So I would guess that some people are going to think this in different ways, like 12 and 10. Some people might think of 4 and 30, maybe 2 and 60. There's so many ways to do this. So I'm just going to do one that people probably picked first, which is 12 and 10. And even though neither of those is a perfect square, if I keep breaking down my numbers and look for perfect squares again or pairs, it's probably going to help me get to where I need to be. So look at this, and that is a perfect square. So I'm going to pull that out and bring that as a 2. These two are not perfect squares. And if I break up 10 again, I'm going to get 5 and 2. And neither of those are perfect squares. So not a perfect square, not a perfect square, not a perfect square. That means I need to just put these guys back together. And that answer is the best answer that we can get. So again, you can put it into your calculator, double check. All right, so the next one. Now we're getting a little longer, and you also recognize that we're getting letters. So letters are handled differently, so I'll do those in a second. But let's do over here the square root of 48 as 16 times 3. Now, if you didn't know that and you use something else like maybe a 2 and a 24, you can still go through this process of breaking it up a lot until you get what you need. I'm going to pick 16 and 3 because that just came to mind, and I know that the perfect square is here. It's going to come out as a 4. It's going to leave the radical 3. So I'm not going to circle it because I'm not done. I have all these variables, so let's break those up. So I need to find pairs inside the 3, a pair of y's, as many as I can, and as many pairs as I can for the 7. So what we're really doing is kind of saying to ourselves, because this is a square root, meaning there's a 2, how many times does 2 go into 3? Well, it goes in once, and then there's going to be leftovers. So I want to show you what I'm thinking. I know there's 3 x's underneath the radical, and I know there's one set of pairs. So that means one x comes out, one set comes out, and that doesn't have a partner, so it stays underneath. So over at the y's, I can think of them separately if I need to and say, hey, look, there's one pair. That means all of them come out. Nothing's left over. Here, I'm thinking of pairs again, but what I'm hoping you're noticing is that when you have odd powers, you're always going to have this remaining factor that sits there while your pairs form. So kind of watch here. Look for that pattern. I could do 7 z's. 1, 2, 3, 4, 5, 6, 7, anyone more? And then circle 1 pair, 2 pair, 3 pairs come out. So z has 3 pairs coming out. Then again, look, there's that one z that's going under. So That's what I'm going to get. Now, there's another way to think of this, and here's the shortcut over here. Some people say to themselves, let's divide the 2 from our square root into the 7 of my power. See what happens. It goes in there 3 times. There's my power of 3. And then there's a remainder of 1. So there's my 1 left inside. So some people like to do this thought when they're breaking up the pairs instead of writing all of them out. Now you got to be careful. Everything that came out is going to go in front. 4x, y, z to the third. And then everything that stayed inside the radical is going to stay right back in there together. 3y, z. 3y, z. And make sure I double check all my answers. So 16 and 3 was 48. 4 comes out. 3, one of the x's came out, 1 stayed under. Y squared, everything came out, so 1 group. And for z to the 7th, 3 groups of 2 came out, but 1 was left over. So again, 4xy, z to the 3rd, square root of 3y, z. That is my answer. Okay, so keep going. Now the only thing I have to worry about now is I got this extra 5, so I'm kind of going to hold him and deal with him later. I'll just keep recopying him down, divide some room here. And then I'll multiply him later. So I'm going to keep the 5 here, but I'm going to break up 60. I could use 12 and 5. I could use 6 and 10. There's so many different things I could use here. So I'm just going to use what I think most people will commonly use, which is a 6 and 10. Not perfect squares. I'm going to have to keep going. I'll break that up later. I'll break that up later. I'll break that up later. Okay. So 5 comes down. Now don't forget it. It's part of my answer. I'm going to bring it down. 6 goes to 3 and 2. 10 goes to 2 and 5. I'm going to keep going there. I'll do that later, okay? So underneath, I've got a group of 2 as a pair. So I had the 5 out earlier, but now I'm going to bring a 2 out. And that's going to keep these guys underneath as a 15. Now I'm going to do this one, perfect square, all of it comes out. Now I'm going to go with this one. Remember, this is a square. That means we've got a power of 2 we've got to think of in our head. How many times does 2 go into 5? Twice. But that's going to leave you a leftover of 1. Now notice I didn't write all 5 y's out, but I could encircle my pairs. 2 pairs come out, 1 stays under. I'm going to try to use the shortcut for the y to the 10th. How many times does 2 go into the 10? 5. So all of those. Oops, I'm sorry. You know what? That's a z. Hello. That's a z. So if you look at the z again, there's 5 pairs. So 5 came out, 2 came out, x came out, y squared came out, z came out. We have 10, x, and y to the 2nd, and z to the 5th. But under we still have left over a 15 with a radical and a y with a radical. There you go. Okay. So we're going to keep going, and I know the letters might be tricky. Just when we try square roots again, just let me know if you're having trouble figuring out why we're looking at pairs. Because now when I go down to here, I'm no longer going to look for pairs because that's a 3. It's groups of 3. This is a group of 3. Look for a group of 3s. And this is a 4, kind of tiny. Sorry, hard to see. So we're going to look for groups of different groups rather than perfect squares. Let me see if I can zoom this in a little tighter. You can really see what I'm doing. Hopefully it's a little fuzzy. Let me see. There we go. Don't like it. Okay, let's get going. So now I need to look for groups of 3. So I'm going to break up 16. Keep that index there. Remind me what I'm looking for as much as I can. So I know it's 2 times 8. So I can say the cubed root of 2 and the cubed root of 8. And now I got to look for groups of 3, which some people know what that is right there, but some people don't see it. So I'm going to leave this guy here. Remind myself I'm looking for groups of 3, and I'm going to break up 8 into 2 times 2, because that's 4 times 2. So now if you look, do you see there's a group of 3 there? So this guy does not come out because he doesn't have partners, but this guy does, so he comes out. But we always want to write anything that comes out of the radical in front. So it's 2 times the cubed root of 2. So looks a little messier, but is correct. So keep in mind when you're simplifying radicals, the answer really doesn't look simpler, but it's simpler because all the numbers that you pick are smaller than what you started. So 3 was smaller than 63 up here. If you look back at the beginning one. 3 was smaller than 63, 7 was smaller. So because those are smaller, they're simpler. Now I'm going to go here. This is a little bit bigger of a number, so we're going to have to go a little slower. So I'm going to come way over here, guys. If I start breaking it up, I see it ends in an 8. So I know maybe a 2 or 4 go in there. So I'm going to try putting off to the side a 4 in here and say that's going to be 32. So I'm going to try 4 and 32 with my cubed root. And then I'll break it up later. So let's break this up into groups of 3. Let's break this up into groups of 3. Ooh, I might have a problem there. Let's break this up into groups of 3. So I'm going to look really carefully at how many times does it go in. Let me make sure that's a 3. Okay, ready? Go back to the big guy. Keep splitting 2 and 2. This to me is 2 and 16. I'll come back later. I already have a group of 3. I like that. But you know what? It's 16th. There's going to be a ton of 2's here. So I'm thinking rather than going to 2's, why don't we stay with 4's? And let's see what happens. And if it works, great. And if it doesn't, we'll go back to 2's. Keep the 4. I'm going to go to 4 and 8 for 32. So now I already have that 4. I already have that 4. That is a 4 times 2. That was such a better choice. Now I'm not going to run into a whole bunch of mess with the 2's because I'm already done with the group here. So one group comes out. This doesn't have any partners, no groups of 3, so it stays under. Now, just like we asked about how many times does this go, how does your square root go into your powers? So like square root into 3, square root into 2, square root into 7. I'm going to go down here. How many times does it 3 go into 4? It goes in once. Come down here, please. Goes in once, but there is still a leftover 3. So let me show you that middle step that you could take if you want. You could write 4 x's out and then just say I have one group of 3. And again, you're looking for a group of 3 because of that index. All right, I'm going to come down here and I'm going to notice there is never ever going to be a group of 3 in this because it's too small. So when your number underneath is smaller, you're going to stop earlier. So there we go. Leave it. This one, 3 goes into 8 2 times, so 2 comes out for the z. But if you look at your division, that's still going to be a remainder of 2, so there's still going to be 2 z's in there. So now we are almost done. Out, out, out. So 4x z to the second, and then the radical, in 2 in x in y squared in z squared. 2x y squared and z squared, and we're done. So a little complicated, just take your time, be patient, think of groups of what you need to take out for, so 3 here, 3 here, but pairs here. So let me know if you have questions. Hope that helps. We're out. Have a great day.